Welcome back to Cloud 42, I'm James. Today we are going to finish up the low profile edge clamping jaws for the mill vise. You'll remember last time we milled the blanks to size and then milled out and finished the slot in the top to accept the little gripper cleats. This time we're going to drill and tap a series of holes in the bottom of that slot to hold the cleats in place, and we're going to mill mounting holes to mount it to the mill vise. Let's go over to the mill and get started. Okay, we've got one of the jaws set up here in the mill, and we're zeroed on the top center of this top back edge. And so the next thing we need to do is spot the holes. There's 9 holes in the bottom here, and we're using a 120-degree spotting drill going 65 thou deep, which should leave the spot just wide enough to turn it into a chamfer around the edge of the threaded hole after it's drilled and threaded. Okay, in high gear, 1200 RPM. Okay, that's all the holes spotted. They all look the same, which is good. Let's grab a drill and drill them out to 1/2 inch depth. This drill needs to run faster. This should run about 1900 RPM. If we get any chatter or chatter that's a problem, I'll back it off and we'll run it slower. Looks good. I like these chips. Okay, that was beautiful. The drill still feels nice and sharp. Those holes look great. And just as a sanity check, an M5 screw will not go into them. Good, because they're supposed to be 4.6 for tapping with a form tap, which we'll do in a minute. Okay, I'm gonna go ahead and drill the other one, and then we'll come back and do the tapping. Okay, I have the mill set up here for power tapping, and what I've done is I've just driven the mill to the known coordinates of this hole, and I've got a form tap in here. Let me get some cutting oil. This is, I think, Tap Magic. And I'm gonna run it really slow, and I'm gonna run it down. Now this tap is gonna probably hit the bottom of the hole, and it's probably gonna slip. And I know these holes are about 1/2 inch deep, and I've got, how much tap here? It looks like I've got just over 1/2 inch of tap, so I should be able to tell when I'm getting very close to the bottom of the hole. Now when this hits the bottom of the hole, I'm sure it's going to slip in the drill chuck. We don't really want to do that a lot, but a little bit's not going to hurt anything, and that's how we're going to keep from breaking this thing. But still power tap, so we don't have to be here all day doing it by hand. And I'm going to run this just about as slow as I can, at least for the first hole. Get some oil in here, hopefully without too many chips. And release the quill, and let's see how this goes. Okay, yep, and we definitely hit the bottom and slipped. Now, I'm just going to zero my quill readout just so I know where that is. Now we'll back it back out of the hole. Great, now we'll drive to the coordinates of the next hole and do it again. And I know that the next one is at x minus 1.2187. Back and forward, a little more oil, and repeat. So I've stopped 25 thousandths before the bottom of the hole because I can see that with my quill readout, and we'll back it out. And we go on to the next hole, which is x minus 0.8125. So G0, x minus 0.8125, and repeat. Some more juice, and let's do this forward. Okay, that's it. Let me check with the screw and just make sure everything checks out. And it does. It looks good. So let me pull this one out, do the other one, and I'll be back when that's done. Okay, I've got one of the jaws set up here in the vise, sitting up on parallel, so I've got room to drill through it, and we need to make the mounting holes. And so we're going to spot these, we're going to drill through with a pilot, and then we're going to run a 3/8 inch drill through just to remove the bulk of the material. Come back with a carbide end mill and bore them out, and then put some chamfers on the edges. So the first tool is a 1/4 inch spotting drill. Got that in the mill now, and let's go. Okay, those are the spots. Next is the pilot drill. And this will run at 1600 RPM. The size of this drill isn't really important. It's, I don't know, 3/16 or something. The only thing that's important here is just to make sure that it's large enough to capture the web of the 3/8 drill that's going to follow. And I said 1600 RPM. Now this hole is partially interrupted, so partway down it'll probably sing a little. Maybe not. That's well into the interrupted area. I was very conservative with this drill cycle, so it's chip breaking and full retract because I did not want to jam up the flutes. Probably wouldn't have been that big of a problem with steel. Not nearly as much as with aluminum. Okay, that's one, and here's the other one. Like I said, this is really conservative. Should be just about through. There we go, that's through. Okay, next is going to be the 3/8 inch drill. Remove most of the material. Now this one definitely needs to be torqued down, because this could screw through the part at the very end when it breaks through. You know, I see a chip on my lens. Let me clean this lens here real quick. There's a little carbon lens pen. Does a great job. I'm not liking the rat's nest there. Okay, that's through. Can I get that off? No, not really. I'm just going to stay back. Interrupted portion of the cut. Okay, if we had a lot more, I would need to change the program and fix that pecking depth. We got away with it because it's just 2 holes. That drill's still relatively cool. These are very nice chips, actually, for a drill. I'm pretty happy with those. Pretty nice. I've seen a lot worse. Could be a little shorter. That would make me happier. Okay, now we're going to switch over to a 1/4 inch 4-flute carbide end mill and bore those holes out to size. Oop. Okay. This one will have a lot of side load, so it needs to be torqued down well also. Now this is going to be down deep in a hole, so I'll stand by with the air gun to blast out chips if needed. Just back up on high. This needs to run at 1800. There we go. Now it doesn't know, the CNC doesn't know how big the hole is, so it's just going to plunge in and then start spiraling out. Now that sounded like it was off center. We'll check it later. As this goes deeper, it's harder to get the chips out. Okay, even deeper. It's hard to get the chips out once you get this deep in a hole. Hear a little bit of chip recutting. Not terrible. Hole finish looks all right. Yeah, it sounds off center too. We'll check it. Okay, now we're going to go all the way to the bottom and do the bore, the clearance hole, and I'll add a little air from the bottom here. Okay. And the other one. Okay, that's it for the milling. Let me grab a chamfer mill. Now the astute among you will note this is not actually a chamfer mill, that this is actually a 90-degree spotting drill, but it works just fine as a 2-flute chamfer mill. Now this needs to run nice and slow so we don't burn it up because it's high-speed steel. Run about 600. Okay. Get a little coolant on there, and let's go. You can hear the beating of the flutes entering the steel. Seems all right. There's more sound than anything. This mill enclosure is made out of plastic corrugated board, and it tends to amplify little sounds like that. Now once it's finished with these top ones, it's actually going to go down and try to chamfer the inside hole as well, which is a real challenge because I think these holes are 608, and that's a 1/2-inch tool. Should have between 10 and 15 thousandths clearance between the sidewall of the bore and the tool. We're running tangentially further out on the tool, so it's making a little bit less noise as it enters the cut. Looks really nice. Chamfer's nice and even all the way around. There's a nice chamfer down in the bottom as well. Let's go over to the bench and take a look. Okay, so we've got 2 jaws made, and I'm really happy with how they turned out. The slot in the top fits the jaw, the little cleats very, very well. There's almost no movement at all. In fact, I can't feel anything there. Mount with an M5 screw. Nice and tight, come down nice and flush, and the screws below the top, so that's very nice. We've got the mounting holes set in here, and I don't know if you can see, even though we took this in 3 depths with the carbide tool, they're very, very smooth. I don't see the seams, I don't see the joints between the different cuts. So those look good. Now, one of the things I did notice is as we were coming around cutting these, at first it was only biting on one side on the first 10,000ths pass. And so either the drill was pushed a little off center, which would be my bet, or we were actually milling them off center. So let's take a little measurement here and see if we can figure out which it is. So measuring from here to one end, we've got 448 thousandths. Let's measure the other end. Web here is 448 and a half. I am going to call that centered. One other thing that I noticed when I was milling these, or when I was drilling them, is that when the spot drill came down and hit to drill these holes, it looked like it was pushing off center. So let's check and see if these things really are still centered. This front wall should be about 124 thousandths. 123 and a half, that's close enough. Now let's see how close these holes are to the front. I'll just try a couple of these. 165, 164 and a half, 165 and a half. So we're about 165 from the web thickness between the threaded hole and the wall. Now let me zero up on this wall and see what we've got on this side. 166 and a half, 164 and a half, 165. So we're within a thou of centered. So I'm very happy with that. Let's take these over to the mill vise, mount them, and see how they work. Well, as if by magic, somebody cleaned up the mill. We've got two new Talon Grip clone shop-made vise jaws. Let's put them in the vise and see how they work. One screw fits. Hey, two screws fit. And here's the other one on the other side. Okay. Those fit beautifully. See how they come together here? Oh, that could not be better. I can't even feel on the top side. I can just feel, but there's a little side play in the jaws, so that's what you would expect. Okay, well, let's say we wanted to mill something. Here's a good victim, piece of aluminum. Let's set up some jaws to clamp that. These are M5 screws, so I need a 3mm hex driver. Where those parts, just those grippers fit in there perfectly. Like they wouldn't settle to the bottom without a little bit of jiggling. See if in the long run we regret it being that close, but it's easy to fix either by stoning the grippers or by stoning or milling out the channel. These screws are probably a little longer than we actually need. sure these are nice and tight. And let's see how they work. Okay. So the idea is you can just set your block of aluminum right there on the edges. And then it will take a bite. Oh yeah, that's pretty nice. That's not going anywhere. Yep, nice little indents where the teeth bit into it. And let's see how much clearance that actually gives us. So the question is, how much of the bottom here do we lose that we can't machine? Let's grab a depth mic and find out. $59. $59.5. $61. $58.5. Okay, so that's perfect. Now we have a way to grab pieces of aluminum and mill the entire perimeter, leaving just a very thin top head on the bottom that we can then flip and mill off the other side. I'm going to call this a success. Well, these were the goal of all the little side tool making projects that we've been working on instead of the tool post grinder. Now that these are done, we should be able to get back to that project. As always, if you like what you're seeing, be sure to give me a thumbs up, subscribe, share with your friends. Thank you for watching.